Hello, Physics 11 students. We're going to see how this goes today. I wanted to get this out sooner rather than later uh, because I know that people are having some issues, a few difficulties with this, and I just want to go over it. It's not particularly difficult, uh, but I know I've had some people talking about coming in, today's Tuesday, on Wednesday perhaps, to get some help. And this is the unit on waves is a little bit confusing uh, for sure when talking particularly about wave phenomena. And it's really just being able to recognize what we mean by wave phenomena for the most part. But hey, that's all right. All right, so on this one, this worksheets, we're talking about wave superposition. And we're talking about how waves interact when they're traveling along a medium. And the whole point about waves is that waves can travel through each other. Uh, that, that waves represent the transmission of energy, not the transmission of matter. So over here, you can see they showed a wave here and this wave here, these two crests coming towards each other, and they move one tick, one dot each time. And so they just redrawn them. You can see that they're closing in, and then they're overlapping each other. And the matter is, when they overlap each other, to take a look and understand how that affects the amplitude of the system coming through. And so we can see that when the two waves are directly on top of each other, then the amplitude is like 2 plus 2 from the other wave, which gives a total amplitude of 4. But it's sort of hard to see how these two waves are interacting. So what I'm going to do is I'm going to go through, I'm going to draw these, I'm going to use two different colors, red and green, and then we'll take a look at the combined wave of in blue or something like that. So this wave here, it comes up like this and comes down like this, and what I've done is moved it one tick. So I'm going to move it one tick, one dot further, and I'm going to just keep on drawing this one wave. And then once I have that one, I'll do the other one, and then we'll take a look at how they combine. So we're just not doing a great job at these. And the hardest part sometimes is just to make sure that you're going just the one dot. Often it's easy to miss one dot. And so there we go. So I'm going to come back, choose green, make sure, there we go. So this one's underneath. And so it come down to here. So it's going to be down like this. And then dot is going to be down like this. And then one dot over is going to be down like this. So we're just taking a look at the waves. And then here, they're down like this. And then because that's one over, and then come down one. It always moves over one dot. And then one dot. All right, so there we see, in essence, the movement of the two waves. You've got this one that's coming up, going across, and the other one coming down, coming toward from the right. And so now we're going to choose blue, and we want to take a look at the sum of those. So here, at this point here, between this dot and this dot, everything is red. So I'm just going to go over the red in there. It comes across, and then it's green because the two waves aren't touching each other. So this is the blue line represents what we would actually see. When we come down to this one here, well, the two waves are touching each other, but they're not overlapping. And so the combined wave, superposition, the superimpose, would look like that. And so then here, we're coming across, and this part of the wave is not touching here. And likewise, we can take a look and see that this part of the wave is not touching. And so this is defined by the red wave, this is defined by the green wave, and so then we have everything in between. So let's take a look at this point here. The value of the red wave is 2, the value of the green wave is 0. Here, the value of the red wave is 1, the value of the green wave is -1. Positive 1 plus -1 is equal to 0. And then here, the value of the red wave is 0, and the value of the green wave is -2. And so what that tells us is that this would be the basic shape of the wave at that point. And so where the two waves are overlapping each other, the amplitudes add together. So now let's come to this one. So here we have no interaction. Here we have no interaction, and so we have interaction in between. So here we have 0 and 0, so that's 0. Here we have +1 for the red, -1 for the green, that's equal to 0. Here we have +2 for the red, -2 for the green, that's equal to 0. +1 for the red, -1 for the green, that's equal to 0. And then we have 0 and 0. And so what that tells us is that right here, at this point, the wave, the spring, or whatever that these waves are traveling upon, even though there is this energy of these two waves, the amplitude is equal to 0. So this would be an example of what we call destructive interference, where the wave amplitudes are destroying each other. Whereas over here, this is constructive, where the amplitudes are adding together and making a larger wave. All right, so that's that point. So then once the two waves move past each other, then we get to this point here. So there's our line. Our green is going down, so it would look like that. Likewise over here, this would look like that. Those are the 2 points. And then we have in between where the green and the red are overlapping. So vertically, we have both a green point and a red point. And so here we have 0 and -2, so that's going to be equal to -2. Here we have +1 and -1, so that's going to be 0. Here we have 0 and +2, so it's going to be up there. And so here, this wave here would look like that. As we come to the next one, coming across, well, the green wave and the red wave aren't touching. And so this would be the result of that. And then here, would look like that. So that's what's happening with the superposition. And it's a distortion of the wave because of the interaction of the amplitudes. Let's take a look at the next one. Well, what? I didn't copy the right one. So let's come to here. We'll take a look at these two. And yeah, we'll see how it goes. So this wave's going to be coming across, comes to here, one more tick, goes up. I should do this in red. Let's do that in red. So it goes up, comes across 2, comes down 2, and then this one here comes, I should do that in green. So this would be here, and because that's one tick, across 2, and then up 2 like that. And as we come down, so this red wave is coming across, comes to here, goes up, comes across, comes down, and the green wave is coming down, comes across, and then up. Now, so we're just repeating those. The wave comes across, comes up 2, comes across, comes down, and then the green is down 2, across, and up like that. And so it's coming across to here, up 2, across, down, and then the green is something like that. And then let's we're just okay. So we could do perhaps one more. No, not really. So let's come in now with the blue and take a look at how these are. So this is going to come across, follows the red, and then they're touching at this point, but then it's just at that point, and so the blue represents the sum of those two. So here we're coming across, we get to this point here before we have any interaction. Likewise for the green, we come to here before there's any interaction. So here we have a 0 and a 2, which is 2. Here we have a positive 1, negative 1. Here we have a negative 2 and a 0. And so the resultant, not doing a great job of drawing that, but you're going to get something that looks like that. Here we're coming across and the interactions happen. So this is 2 and 0, so that's going to be 2. So here we have a 2 and a negative 1, so that's going to be 1. Here we have a positive 2 and a negative 2, so that's going to be 0. Here we have a negative 2 and a positive 1, so that's going to be a negative 1. And here we have a negative 2 and a 0, so that's down here. So we would see at this point, the wave would look like that. So come across, so just shoot up, come down, and then come across like that. When you take a look at the next one, so it's going to be coming across, and then it's going to be following the green line down. Here we have negative 2 and positive 2, so that's going to be 0. Negative 2 and positive 2, 0. Here we have positive 2 and a negative 2, 0. And then what we have, so we're going to see this come up, right? And then we have come across, and this comes up, and then comes down like that. And then here, the two waves are past each other, and it looks and so for these pulses traveling along a spring or something like this, the blue represents what we would see. Yeah, let me see if I can pull it up. Back one page. Just get this in here, and I have to resize it. This is why I do this stuff generally before. Excuse me. Just make this smaller so we can see it. That's probably pretty good there. Let's try that. All right, so we're going to do the same thing and just see how things come across. And so we'll start with red. And so red comes up, comes down, comes up like that. And then come down here, red comes up, comes down, comes up like that. Move one across, up, down, up. And then it comes up, comes down, and then up. Like that. I know I'm doing these different ways. The last one I was doing green wave, red wave, green wave, red wave, green wave. Here I'm doing all the red waves. And in some ways it really makes more sense just to do all of one wave and then come back. Just because we're looking at the interaction between these. So here we're one step closer. Oops. There, there. Sorry, I'm just trying to make sure I'm getting these lined up right. Yeah. Okay, so that's what the two is so silent. We're working hard here. All right, so that's what the two waves interacting would like. So coming across here, this is pretty straightforward because there is no interaction. And so that's what your wave would look like. I have a hard time on that slope. All right, so then this next one, we're just touching. So this has come up like this. And then here it's coming across, up, down to here. And likewise, this is here to there. And so we have +2 and 0 for the red. So that's going to be up here. Here we have -1, +1, so it's going to be right there. And so what we're going to get is a line that comes like that, the slope, steeper. So it's here, we're coming across, or go up, come down. This is coming across, comes down, and comes up. And so here we have the two over top of each other, 0 and 0, +1, -1, +2, -2, +1, -1. And so what we get here is that destructive interference. We get this blip coming up, goes across, come down, like that. So as we come across here, this goes up. And then what we have is a +1 and a +1, so that's a 2. Here we have a 2 and a 0. Oh, sorry, I should, like this, and then we have got this here. And so we're going to have this little flat spot at top. Then we have, what we're going to see is that this would come straight down like that. And then here, at 6 seconds, it's going to come across, but we have on top of each other, 0 and 0. Here we have +1 and +1, so that would be up here. And we have +2 and +2, so that would be up here, +1 and +1. And then we get to 0, and then we have -1, -1, and then -2, -2, -1, -1. And so we're going to get a wave that goes higher, comes down lower, and up like that. And then here it's coming across, comes up, and then +1, +1 comes across like this. Likewise, this down here comes here, -1, -1 looks like that, and then these are connected like that. And then here, this comes across like this and comes down. This is coming down, up, like that. But then here we have +1, -1, 0, +2, -2, 0, +1, -1, 0, and so it's going to look like that. All right, so that's this worksheet, ladies and gentlemen, and thanks for being here. Short quiz tomorrow. I'm thinking, sort of finish these things off. I want to do the briefest of studies just on special relativity, just to sort of give you an idea. I've been looking for a video. There's that perhaps explains some of these things. There's some interesting videos on Einstein and his discoveries in his life. Kind of an interesting story. Some things that I didn't even understand. I've even read a book about him, but maybe I've forgotten some of it. But how he had a wife, and he married a classmate of his, and they had a couple boys together. And there's some thoughts that some of his earlier discoveries and published papers were due, for a large part, on her effort and her work, and but that he got the credit because she was just a woman. That sort of idea. And some of this comes out in some of the movies that we've seen, and I'm not really sure how, well, I don't know how true it is. I mean, it makes for a salacious story, because he eventually divorces her or leaves her and hooks up with his cousin, actually, and they have a relationship, and she comes over with him to the United States. and when he's fleeing Nazi Germany. And so, anyways, there's the idea of Einstein and some of what he does, and then there is the whole story behind. Uh, People always have stories, and that's can make things interesting. All right. Anyways, we're really close to being done. What we're going to be done for the course. This is really the last part of the waves that we're going to be talking about, and as I say, we'll have a short quiz tomorrow. Hey, thanks for tuning in. Don't forget to like, subscribe, and turn on notifications. Just kidding. All right. Have a good day.